Good morning, students. Myself, Kaushik Ghosh, your physical science teacher, and today's video lesson is for class 9. The chapter which we are going to discuss is matter, its structure and properties. In the earlier video lesson, we have discussed about the first module of this chapter. Today, we will discuss about the second module, that is Archimedes Principle, surface tension and viscosity. Let's start. Okay, so here we will discuss the term buoyancy. Now we must have experienced this example here. You can see whenever we try to put a ball deep inside the water, we feel an upward force acting on our hand rather on the ball. And the moment we leave the ball jumps out of the water as if somebody has lifted that ball upward. Now the nature of this liquid, or the property of the liquid due to which it exerts an upward force on an object which is partly or completely immersed in it, is known as buoyancy. So it's the ability or tendency of something to float in water or some other fluid, or the power of a fluid to make a body float in it. Fluid means both liquid and gas. Now the buoyant force is the upward force exerted by the fluid on an object that is wholly or partly immersed in that fluid. This upward force is also called upthrust. You can see here the object which is inside the water is acted upon by two forces. First, its own weight which acts in downward direction, and secondly, the upthrust or the buoyant force which is given by the liquid on this substance in upward direction. The principle of working of submarine is also based on this property of buoyancy. A submarine has got few tanks inside it, which is known as ballast tank. When the submarine wants to submerge deep inside the water, it fills up its ballast tanks so that its weight increases and it goes down in the water. When it wants to rise up, then what it does, it takes out the water from the tanks by air compressor and make itself light in weight, so that with the help of upthrust of the liquid it rises up. Also, the working of hot air balloons is also based up on the property of buoyancy. Now similarly, all the ships, lifeboats, life jackets, all these things work on the principle of buoyancy. Now we will discuss about the factors which affect the magnitude of buoyant force. These are: number 1, volume of the immersed part of the body in the fluid, means the volume of the substance which is inside the fluid. Number 2, the density of the fluid in which the body is submerged. Now how does the first factor affect the buoyant force? With the increase in volume of a body immersed in a fluid, the upward buoyant force also increases, means more the volume inside the liquid, more will be the upthrust given by the liquid. Means suppose a 50% of the substance or half of the substance is immersed inside the liquid, and let be the upthrust be F1. And now what we are doing, we are submerging it more, means 3/4 of that is submerged inside the liquid. Now as the immersed part of the solid increases, so what will happen, accordingly the upthrust also will increase. Now let the upthrust be F2. So we can say F2 is greater than F1. So more is the volume immersed, more will be the upthrust on it. And density factor, how does it affect? Now as the density of the fluid in which a body is immersed increases, the buoyant force exerted by it also increases. Means if we consider normal water and salt water, as we know that salt water is having more density than normal water, so obviously salt water will exert more upthrust than normal water. That's why in Dead Sea, objects float because of its maximum density. Magnitude of buoyant force is independent of the nature of solid object and depth in which the body is immersed. So these are the two factors which do not affect the magnitude of buoyant force. Now we will discuss the terms density and relative density. Although you are well aware of these two terms because in lower classes you have learned about them. But just a quick recapitulation about these two terms. Density of a substance is defined as mass per unit volume of a substance. We can write density as m by v. So if v becomes 1, d becomes equal to m. That's why it is written density of a substance is defined as the mass per unit volume of a substance. What is the SI unit of density? Mass by volume, so kg per meter cube. And similarly in CJ system of units, it is gram per centimeter cube. Dimension, mass by volume, so m divided by L to the power 3. So if you take it, it will become m L to the power minus 3. Relative density is defined as the ratio of density of a substance to the density of water at 4 degrees centigrade. So we write relative density as ds by dw. Now density of substance is equal to mass of substance by volume of substance. And similarly density of water is equal to mass of water by volume of water. Now if I take the ratio, so it becomes ms by vs divided by mw by vw. Now if vs becomes equal to vw, means these two terms vs and vw, if they become equal, then what will happen? Then relative density will become ms by mw. That is, relative density of a substance can also be defined as the ratio of mass of any volume of a substance to the mass of equal volume of water at 4 degrees centigrade. Remember one thing, when you are trying to define the relative density in terms of masses of substance and water, then please keep it in mind this equal volume of water you have to write. The volume of the substance and water should be same. The relative density of a substance expresses the heaviness of a substance in comparison to water, means how much an object is heavier with compared to water, that is given by that relative density of the substance. And as the relative density is a ratio of two similar quantities, as you can see both are densities here or both are masses here, it has no unit and no dimension because the units cancel out each other. Now we will discuss about Archimedes Principle. We feel that it's quite easy to lift a bucket full of water inside the water of a well, whereas doing so in air is relatively harder. Here water appears to give partial support to any body placed in it, and the upward thrust exerted by water on a body placed in it is called buoyant force or upthrust. When a body is immersed partly or wholly in a fluid at rest, an upward force, that is upthrust, acts on it. Archimedes' principle is based on this upthrust, which states that when a body is immersed partially or completely in a fluid at rest, it experiences an upthrust which is equal to the weight of the liquid displaced by it. Now my dear students, as you can see here, an object which is outside the water, that means in air, its mass is 5 kg, let the weight be 5 kg force, and when it is submerged completely into that liquid, that means the water has come up here through this spout, and I have collected that in a container, and that is coming as 2 kg of water, means mass here. So the weight of this water, collected water, is 2 kg force. That means the upthrust which will be acting on this object, that should be 2 kg force. Why? Because that should be equal with the weight of the liquid which has been displaced by the body when it got submerged completely. Understood? Okay, now here when a body is immersed partly, means partially or completely in a fluid, then the body appears to lose a part of its weight due to the buoyant force acting on it, and this reduced weight of the immersed body is called its apparent weight, means the loss in weight. So if the weight of a body in air, it is W1, and the same weight when it is submerged in the liquid, the amount of liquid which got displaced by that submerged part of the body, then that be W2. Then the loss in weight, that means the apparent weight will be the difference of these two weights, that is W1 minus W2. So in this diagram, what is the loss in weight? 5 kg minus 2 kg force, that is 3 kg. Now we will discuss about flotation. When a body is kept on the surface of a liquid, two forces act on it, one in downward direction and one in upward direction. The force which acts in downward direction is its own weight, that is W, and in upward direction, weight of the liquid displaced by the body, that is the buoyant force or upthrust, acts, which is given by the liquid on the object. Now there are three laws, or rather three conditions, depending on which a body floats or sinks in a liquid. First, if W becomes more than U, means weight of the body becomes more than the upthrust. That means what? The downward force is more than the upward force. So obviously the body sinks. As you can see here, downward force more than upward, so it sinks. Second condition, if W becomes equal to W, means body floats completely submerged. What is mean by this? Weight of the object is equal to the upthrust or buoyant force. So they balance each other, these two forces. That's why the body floats completely submerged, means it will float just under the liquid surface. Third condition, W is less than U. In other words, we can say U is greater than W. Means here upthrust is more than the weight of the object. So upward force is more than the downward force. That's why the body floats partly immersed. This is the condition, third condition, where U is more than W. Now we will discuss about the topic surface tension. We know that during rain, raindrops falling downwards are spherical in shape. When a paintbrush is dipped in water and brought out, its hairs cling together. Certain lighter insects like spiders and mosquitoes are able to crawl over free surface of water. When some oil is poured on water, it spreads over water. Rainwater cannot pass through the clothes of an umbrella or a raincoat. All these are due to the surface tension, by virtue of which the surface of a liquid behaves like a stretch membrane and the membrane is under tension, and as a result, the free surface of the liquid always tries to contract so that it possesses then least surface area. For a given volume, surface area of a sphere is the least, and hence raindrops appear spherical in shape. When the paintbrush is immersed in water, the hairs of the brush remain separated, but when it is taken out of water, the hairs stick together because a film of water formed between hairs contract. Lighter insects are able to crawl over the free surface of water because of the property of surface tension. As the force of surface tension of oil is less than that of water, oil spreads over water while water does not do so over oily surfaces. Through the fine pores of an umbrella or a raincoat, air can flow through but not water. Because of surface tension, water takes the shape of small spherical droplets and rolls down over the clothes of an umbrella or a raincoat. Hence, surface tension is a property of a liquid by virtue of which the free surface of the liquid behaves like a stretch membrane tending to contract so that it can possess the least surface area. See, surface tension is the amount of force acting per unit length on either side of an imaginary line drawn on a liquid surface at rest. As you can see here, this is the free surface. The liquid is in rest. So this is the free surface. Now the imaginary line drawn on the surface of the liquid, I have shown you the magnified view of that.
This yellow color line is given here. Now the force acting on either side of this line means either left side or right side, and this amount of force acting per unit length is known as surface tension of that liquid. It is expressed in terms of force and length, so force divided by length. So the units are in CGS system dyne per centimeter, and that is in SI system Newton per meter. Dimension of surface tension mt to the power minus 2, because dimension of force is ml t to the power minus 2 and dimension of length is l. So l cancels out, so what remains? m t to the power minus 2. Now the factors affecting surface tension of a liquid. First factor is temperature. Surface tension of a liquid usually decreases with increase in temperature of the liquid. Beyond a certain characteristic temperature of a liquid, which is called the critical temperature, surface tension of the liquid vanishes. So from here you will get the definition of critical temperature. Number 2, presence of dissolved substances in a liquid. Inorganic dissolved substances, if they are mixed with that, surface tension of the liquid increases, and if the substances are organic, then surface tension of the liquid decreases. Please keep this thing in mind. Presence of impurity. Due to the presence of impurity, surface tension of a liquid usually decreases. Nature of the medium in contact with the liquid. Surface tension of water in contact with dry air is more than surface tension of water in contact with moist air. So these are the factors which are affecting the surface tension of the liquid. Electrification of the surface, one more is there. Surface tension of a liquid usually decreases if the surface of the liquid is electrified. Now we will discuss about another property of matter is known as viscosity. When we pour equal volume of water and honey in two identical funnels, it is observed that the water flows out of the funnel quickly, but honey flows down very slowly. This is due to the different internal friction acting in the two liquids, and the phenomena is known as viscosity. The greater the viscosity of a fluid, it is less easy for the fluid to flow and the more sticky it feels. Now here what we have done, we have taken a beaker and fill it with water. Now put a glass rod in the beaker containing water and start rotating the rod. What will be our observation? It is seen that water starts rotating and takes the shape of a cone. It is also seen that speed of rotation of water is maximum at the center, but least near the wall of the beaker, which indicates a relative motion between the different layers of water. Keep watching what happens after some time. After some time, what will be our observation? We see that the motion of water stops naturally, and what is the reason behind it? Actually, no external force has been applied to stop the motion of water, but some internal forces opposing the relative motion between different layers of water come into play, which stops the motion of water. This force is known as the viscous force, and the phenomena is known as the viscosity. Rather, the property is known as the viscosity. So viscosity of a fluid is defined as the property by virtue of which the fluid opposes the relative motion between its different layers. Both liquids and gases exhibit viscosity, but liquids are more viscous than gases. Different liquids possesses different viscosities. For example, honey is more viscous than water, but coal tar is more viscous than honey. Now we will discuss about streamlined and turbulent flow. A flowing liquid consists of a number of liquid layers lying on one above another. Now, liquid flow may be classified into the following categories, that is streamlined and turbulent. Streamlined flow in fluids is defined as the flow in which the fluids flow in parallel layers such that there is no disruption or intermixing of the layers, and at a given point, the velocity of each fluid particle passing by remains constant with time. Now in this figure you can see here a streamlined motion has been shown, in which velocities of fluid at any particular instant of time at the points P, Q and R on the line of flow AB, and let that be V1, V2 and V3 respectively, means the velocity at P is V1, velocity at q is v2 and velocity at r is v3. Then as the fluid flows at any later instant, the velocities of the fluid is still v1 at p, v2 at q and v3 at r and so on. Means whatever liquid will pass the point p, all will have velocity v1. Whatever liquids will pass point q will have velocity v2, and whatever liquid will pass point r will have velocity v3. If such thing happens, then that kind of flow is called streamlined flow. There is a special kind of streamlined flow if the velocities of all the molecules of a fluid on one streamline be same throughout its motions, then the special kind of streamlined flow is called laminar flow. Okay, so you can see here, means all the molecules of a fluid, they are having same velocities throughout the motion, then that is known as laminar flow. And if the magnitude and direction of the velocities of the fluid at a point or at any point of it change irregularly and continually and never remain constant, then that kind of fluid flow is called turbulent flow. So you can see here, this is turbulent motion, as you can see. There is a characteristic maximum velocity of the flow of a fluid called critical velocity, up to which a fluid flow is called streamline, but beyond which the flow becomes turbulent. So at very low velocities, we know fluid flows in steady state, velocities increases at certain limit as it gets converted, in slowly into turbulent flow. Now the velocity below which the flow is streamlined and above which the flow becomes turbulent, that particular velocity is known as critical velocity. Means in simple words, below critical velocity there is a streamline motion, and above critical velocity it is turbulent motion. Now we will discuss about terminal velocity. Whenever an object falls through a fluid, two forces act on it. One, its own weight, which is acting in downward direction, and another, the viscous drag force, which acts in the opposite direction, means which tries to oppose the motion of the object. Now this viscous drag force increases with the increase in velocity. After a certain time, the weight of the ball becomes equal to the sum of upthrust and viscous drag force which is acting on the ball. There are two forces actually acting in upward direction. One is the upthrust and another is the viscous drag force, which is due to the viscosity. So at this moment what happens? No net force act on the ball because total downward force become equal with total upward force, and the ball moves with a uniform velocity which is known as terminal velocity. The terminal velocity or terminal speed of a body is the constant maximum velocity acquired by the body while falling through a viscous fluid. And at the terminal speed, what we can see, the total upward force, that is upthrust plus viscous drag, the sum of these two forces become equal with the weight of the object W. This terminal velocity for a spherical body is directly proportional to the square of its radius, and for this reason a larger raindrop falls with a greater velocity than a smaller raindrop. While jumping down from an aeroplane, after some time the jumper along with the parachute falls with the terminal velocity, and as the velocity is of small magnitude, the jumper can reach the ground safely. The next topic is rate of flow of liquid. When a liquid flows through a horizontal pipe, then the rate of flow of liquid through this pipe can be determined with the help of Poiseuille's formula. Now it has been found that the volume of the liquid flowing out per second through a capillary tube varies. How? You can see here, directly as the pressure difference, means P, between the two ends of the tube. So this is the tube. Let the pressure difference between these 2 points is P. So first, the rate of flow of liquid per second. Rate means only flow of liquid by time. So that is coming as directly proportional to the P. Next, that is directly proportional to the fourth power of the radius of the tube. Third, it is inversely proportional to the length of the tube. and inversely proportional to the coefficient of viscosity, means eta. Here you can see this is the rate of fluid, delta V, amount of liquid flowing, it's a volume, divided by time, small time, delta V, proportional to P r to the power 4 by this symbol is called eta. It is known as coefficient of viscosity. So P r to the power 4 by eta L. With the rise in temperature, viscosity of liquid decreases, remember, but viscosity of gases increases with the rise in temperature. Viscosity of liquids increases with the increase in pressure, but for the first few hundred atmospheric pressure, viscosity of water decreases with the increase in pressure. Although viscosity of gases is independent of pressure. So this is very important thing to remember. My dear students, please take a note of this, and while you study, pay extra attention in this particular part. Hope you have understood the lesson. Now go through this lesson twice or thrice, then read the topics from your textbook, read the chapter thoroughly, and I'll be back soon with the remaining part of this chapter, means the last module of this chapter, that is Bernoulli's theorem and elasticity, and I'll be also giving the assignments in the next video lesson. Till the time, stay home, stay safe, take care. Thank you.